Okay, now let's start. When in your entire AS, you actually have like two compulsory units, and then again one, two, three, four, five optional unit. Okay, out of the five optional units, you can choose any of two or any of one for AS. So basically, this is how the in maths the units are quite like I would say disturbing or not that much clear, because in other subjects, for example, if you're with maybe um, physics, chemistry, or any other subjects, they have fixed units. In AS, you'll sit for only 3 units, and in A2, you have other 3 units or other 2 units. But for maths, you have compulsory 4 units, and for optional 5 units. So let's just write the compulsory units first. For compulsory units, you have Pure Maths 1, that is P1, then again Pure Maths 2, Pure Maths 3, and Pure Maths 4. Okay, these are your 4 compulsory units, and you have to specifically take them all to complete your entire A levels. And for optional units, you have M1, M2, S1, S2, and D1. Okay, now exactly which are the units that you are supposed to take in AS and which are the units that you should take in A2. Over here for AS, basically for the compulsory sections, P1 and P2 is considered as AS, and P3 and P4 is considered as A2. And from the optional units, for all the 5 units, you can take any of the 2 units. When you put entire A levels, you have to choose any of the 2 units out of that optional 5 units. Now, in most of the cases, to be honest, I have seen that for A levels maths, people take M1 and S1. Okay, M1 is mechanics 1, and mechanics 1 basically deals with your concepts about physics and maths combination. I mean, you will come across questions from F equals to ma, Newton's second law, Newton's third law, and you will have questions from pulley, force, body, free body force diagram, and all of these questions that would that is related to your Newton's laws of motion. Then again for kinematics, that is the constant acceleration equations, and after that you have moment and momentum. Okay. For M2, that is again an extended unit of mechanics. This is mechanics 2. Over here, you will see projectile motions, then center of mass calculations, and then again momentum will also be a part of this mechanics 2, and a few differentiation integration, but not that much extreme. It's very small kinematics in 3 dimensions and vectors for M2. In most cases, M2 is obviously tougher than M1, because as you can understand, this is like the what second unit, right? Second unit for mechanics. This is certainly tough. This one is easier. Like the S1, M1, D1, all the 1 units are easier, and the second units are obviously a little bit trickier than the first units. And then you have S1 and S2, that is for statistics. This is statistics 1, and this is statistics 2. For statistics 1, I mean, for statistics, you will actually come across the maths which are needed to understand the sample size. We needed to carry out an experiment where again, these type of maths are again needed to understand the mean, mode, median, pie charts, histogram. All of these calculations are part of your statistics 1, statistics 2. And then again, most of the people try to take statistics 1 rather than statistics 2. And for D1, for all of you in your O levels, I think all of you had your IGCSE Maths B or Maths A or further pure maths, right? In Maths B or Maths A or further pure maths, doesn't matter whichever you took, you did some of maths from these all 4 units. I think if you did Maths A or Maths B or pure maths, then there was a section about kinematics where you'd have to find out the final velocity of the particle, where the object would start with certain amount of initial velocities and acceleration and velocity. Right, those are the again kinematics with much more like similar kind of maths are taken to this unit M1 and M2, and for your S1 again in IGCSE Maths B and in Maths A. In only those 2 units, you have seen statistics. It was not a statistics was not a part of further pure maths, but it was a part of Maths B and Maths A. For Maths B and Maths A, statistics was mostly about histogram, pie charts, ratio percentage, and mean mode median, and what else? Ratio, pie chart. Map scale was also considered as a part of statistics. Other than that, we haven't seen anything out of this like mentioned names from the statistics. Can you guys just wait 1 minute? Hello. Okay, I'm really sorry. That was actually an important call, and I had to take that. As I was saying, that for from your IGCSE Maths B and Maths A, you have an idea, like little bit idea about statistics also. But for D1, you do not have any idea about Decision Maths 1. Okay, Decision Maths 1 is entirely related to your back end of programming languages. I mean, if you have ideas about Python, only Python is, to be honest, necessary for D1. Other than that, it is a plus point if you know a little bit about C++ or maybe a few functions about HTML and what else? Java is not that much required. I mean, you can do algorithm in Java also, you can do algorithm in other languages also, but Python is the easiest language. So, I mean, for D1, it's not like that it is compulsorily that you have to and must have Python, must have knowledge about the Python language. But mostly, the Decision Maths 1 is for the people who's going to take like IT in A levels, or maybe is going to study CSE, like computer science and engineering in the further studies, or maybe even in any kind of engineering, to be honest, there will be at least one or two courses where you will have to come across with the programming languages, because nowadays I can build up anything using programs, right? So D1 is considered as a part of algorithm. Now, then again, I cannot explain what algorithm is. So, um, it's entirely related to your IT subjects, okay? Not related to your other units of maths. So far, we have seen all the units except for D1. I think for Afti, his school is like making this compulsory that they need to take D1 in maths. So for him, he has already decided that he's going to take like P1, P2, these two compulsory units, and D1 for the AS section. And other than that, if there is like no nothing compulsorily, that in that case, I would suggest always take M1 for AS. Okay, because M1 is entirely physics unit 1. I mean, if it is not compulsorily, if your hands are entirely open, you can choose your units. I would suggest that would be a proper selection of units, because D1 is related for people who have IT, then they should take a D1 in AS. Okay, for them, it is certainly required, because for IT, again, for theoretical part of IT Unit 1, that requires a little bit about algorithm knowledges that we're going to teach in D1 classes. But for other people who does not have IT, or like do not actually intend to learn IT or Pythons, or something related to programming, D1 would be not necessarily compulsory for them to take in that in AS. So I think for Fayad, he also decided that he's taking M1 in Physics Unit 1. And for Shira, have you decided which unit, optional unit, you are going to take for AS? I think Shira, you're in the same course, same school as Abir and Sharon, right? Yeah, then I think Afti is also from your school. I think that's Sri Lankan school or something, right? Can Afti please tell me your school name?
Yes, teacher. Stafford Sri Lankan School.
Yeah, then I think as Afti already told me that it is compulsory for this year to take D1 for you guys. So I think for you guys, for both Shira and Afti, you are supposed to take D1 for AS because I think that's what your school is making it as a compulsory unit. Right. I think for school candidates, you do not have an option to choose the optional units. The school will arrange your units for AS and A2. And for Fayad, as you're from Khazanchi Bari, they're not going to force you to sit for any units. Okay, I have students from there also. So you can choose from any one of the units for M1 or S1. I think for Khajanchi Bari, if you want to study M2, S2, and D1, that they might not be able to provide you classes for, but for M1 and S1, you can choose any of the two units. Okay. So, so far, I'm considering that since Afti told me that D1 is compulsory, I'm assuming that I think that would be same compulsory for you too, Shira. And Fayad is going to sit for M1. So in that case, I mean, for P1 and P2, our classes will be different, and for the optional units, our classes are actually different on a different timing. I think we have our 1 minute. Let me just write down the routine first, and then we will start. Okay. For P1, we have classes on Sunday and Tuesday at 1 minute. P1. This is basically an optional classes to be honest. I mean, like optional means that we are going to first start with P1 and then again from this year October we will start with P2. Okay. So I'll just write P1, P2 like optional P1, P2 classes. These are the routine for P1, P2 Sunday and Tuesday. If you are like Fayad, you're from Bangladesh, so it's going to be 2 p.m. for you, and for Shira and Afti, you're going to have classes at 11 a.m. of your time. And D1 class timings are not actually decided yet. I mean, after this trial class, we'll decide that in which routine will follow the D1 classes. And for Fayad, your M1 classes are fixed. For M1, we are maybe taking classes at Wednesday at 2 p.m. again. These are the class timings. Yes, for M1, Wednesday at 2 p.m. Right. Okay, now these are the optional units, but then again for Shira and Afti, there's not to be honest an optional case. But yeah, other than that, this is how the overall units for maths. Now again, what is our planning over here as we're starting from tomorrow, right? Tomorrow is your July 1st. Not exactly tomorrow. Our classes will then start from Tuesday for maths. Our classes will start from 2nd of July this week Tuesday at 11 a.m. and 12 p.m. for different time zones. So for Tuesday, since we're almost starting from the 1st of July, we will have enough time to complete few units earlier in the Jan session. So I'm actually hoping that the optional units does not actually have that much big content. For example, for D1 and for M1, you guys can actually sit for the D1 and M1 units for the Jan session, and then again for P1 that can also be sat for the Jan session because P1 have a lot of content to be honest. It has like 8 chapters for P1, but the contents are not that much tricky. Like in today's class, we'll complete 20% to 30% of chapter 1 because that's so easy to explain and even for you guys to understand because that's just basic maths B, maths A, or further pure maths. Whatever you had in RGCSE maths B or RGCSEs, that is just an extended version of P1. Like P1 is extremely easier compared to your questions that you saw in maths B, maths A, or pure maths. Right, P1 is easy, P2 is a little bit tricky, but not again that much extremely tough to understand. P2 is a little bit lengthy, I would say, but not that much tricky. And P1 is extremely easy. You just have to be more consistent and practice a little bit. Not like that, you need to practice it a lot, but a little practice is much required. For M1, you have to practice a lot, and then again for D1, you have to practice a lot. I mean, for D1, you guys have to actually provide a much more effort because that's entirely new. Like it's entirely different from all of the things we saw in basic maths till now. So D1 is quite unique for those of you who are sitting for D1, they need to actually, focus a lot and practice a lot as much as you can. D1 is a little bit different compared to all the units you had so far. So let's start with P1 today. But before we start with P1, let me just go back 1 minute. Then again, this is how we actually distribute our classes, like make our classes assigned. This is going to be your classroom for your May 2025. And obviously, do not try to find anything from the stream section. That's confusing. You can't find everything from this like classroom section. Okay, for classroom section, I'll always arrange every topic under one heading: chapter 1, chapter 2, chapter 3, similar heading. And obviously this is your like first chapter, so I do not have anything to upload before your classroom, so this is the only file that I could upload. This is the formula for chapter 1, like all the formulas compiled for chapter 1 is written under here. Okay, so we're going to use this formula sheet, and then we'll move on to your uh, main chapter 1 concept for P1. But if you want to see exactly how does my other classrooms look like, then I do have my, yeah, this is for the P1, P2 October batch. But as you can see over here, for them, I have created different sections: chapter 2, chapter 3, chapter 4, and their class recordings and class slides. What is basically class slides? Class slides are actually everything that I solve in your classroom or inside your class during your class that is referred to as your class slide. And all of the class slides are always added to your classroom. Okay. These are like notes that I take in class, and this will be added in your classroom. So maybe if you missed something during the classes, you can obviously write those things again on your copy using this class slides. And another thing, the class recordings are given again under every chapter. But if you want to go through all the class recordings, you can go to the stream. Wait 1 minute. Yeah. And this is how the class recordings will be for your for your classes also. This is like the class recordings for P1 for them, and it will be similar to them for you also, for you guys, for your classrooms also. Right, then again, these class recordings are actually uploaded in YouTube privately, and these recordings will only be shared with your email with which you will join this classroom. Okay, so if you guys want to continue with our classes, make sure that you join the classrooms with your email, which you have like complete access to. You have the password, you have the like Gmail ID or everything you need for that. Okay, let's start with your classes. Now, there are a few rules we're going to start. For P1, Chapter 1, if you go there, this is your book, by the way. The book PDF will be uploaded to your classroom, but I would suggest that obviously you guys need to practice a lot from your book eventually. So try to buy these books from your local stores. For Fayad, do you have the books available already to you?
No, miss.
Mm, okay, then I'll send you the names for the book. Try to find out and buy these books within this week. Okay.
Thanks.
For maths, we're actually going to follow the book suggested by your Pearson at Excel. But for Afti and Fayad, since you both are again in my physics classes, we're not going to follow the book suggested by your Edexcel Pearson. For that, I would suggest buy the Hodder book. That's more effective rather than the Edexcel Pearson student book one. Again, the names and the files, PDF files will be given to you guys in your classroom. So we are going to start with the first chapter, that is algebraic expression. And obviously we have did this kind of maths already in our IGCSE classes. So let's just start with the formulas. Let's just get introduced to the formulas first, and then we will start with the main maths from your books. Okay. Now for the first formula over here, as you can see, a to the power of m and a to the power of n can be written as base a m plus n. So for this part, wait 1 minute. Right. For this part over here, one thing is common that both the like in this case for the powers to get added, the bases must be same, right? So they must have the same base. That is a requirement over here. same base. And then again in the next part you have a example over here that x power 2 multiplied with x power 3 turns to give you x power 5, right? Over here they both have the base x, so that's why we could add their powers together. 2 plus 3 turns out to be 5, right? That's how you're going to get 5 on the power for base x. And then again, if you have division, similar concept to one, but this time now the same bases with different powers are divided. For multiplication, you get addition in the power section, and for division, you get minus in the power section. And the fact that the assumption over here is again same, that the bases must be same, right? And there's an again quick example. 5 divided by 2 is basically 5 minus 2, which will give you x to the power of 3. And then whenever you have power on top of another power, only in this cases the powers will get multiplied together. Eventually it will look like a m n, right? If you multiply them, it eventually can be as over here we're working with alphabets. Alphabets can be written one after another if they're in equation they're getting multiplied to each other. In this example, as you can see, x to the power of 5, then again whole square. That means now this 5 and 2 will get multiplied together, and eventually you're going to get 10 as a final power for this base x. Similarly, wait 1 minute. Okay. Over here for 4, as you can see, they have different bases but common power, right? That's why I'm writing a b to the power of n. That means both over here is considered as a base for power n. So I can write a power n and b power n. And that again is an example over here, x square and y square. And that is not the case only for multiplication. You can apply this on cases for the situation when the bases are in divided format. In that case also, whole power always means whatever you have inside the brackets, they will both share the same power. Okay, doesn't matter if the numbers inside the bracket are in multiplied format or are in divided format, they both will have the same power. That's why I took the power as a comment in the first case, right? And over here, similar case, if you have like four quantities inside the bracket, that rule will eventually be same also over here. Everything inside the power will have the same power. Like everything inside the bracket will have the same power. And lastly, this one, a to the power of minus n indicates 1 over a. For example, if you have 1 over a square, right? In this case, your a square belongs to the denominator, right? But what if I want to take this a square from the denominator to the numerator? Only there will be one change, is that the power of that alphabet a will become negative. If I want to write this a with beside 1 that was in the numerator, I can multiply this with the numerator. Only difference is that you will have a negative power on top of that. Previously, you have this positive power when the alphabet was in the denominator, indicating that okay, this alphabet now belongs to the denominator. But if I want to write this entire statement not in fractions but in terms of a straight line, one straight line, then I can multiply the denominator with the numerator. Only difference will be now the denominator will have a negative power, right? So whenever you bring out anything from the denominator to the numerator section, it will have a negative power. This change in position will always create a negative power. Is there any problem till now regarding like up to question 7? Any question till now up to formula 7?
No, miss.
No, teacher.
Okay, if there is no problem, formula 8 is a little bit tricky, so let's solve this over here. Okay. For Formula 8, I would actually need to explain another thing. For example, if you have A in the numerator and B in the denominator, right? I'll write this as A and B, no problem with that, right? They have single numbers, single alphabets in the denominator and in the numerator, right? So there's no problem with that. But if the alphabets are maybe A divided by B divided by C, in this case, now your numerator is already in a divided format, and then again that numerator is further into a division with another number, right? Another alphabet over here. So for this kind of situations, what happens? is I'll write down the numerator separately and then the denominator separately, which is going to be a divided by b multiplied with 1 over c. Right, I have written the denominator separately. And why is that 1 over here? Because c originally belongs to the denominator, right? So if I want to write this separately, there must be something in the numerator. Because c belongs to the denominator, I cannot just write this and c. There must be something over here. I cannot write, like, keep that space as a blank. So that's why I'm just filling up that blank using that 1 over here. So this one only indicates that c belongs to the denominator and there was nothing in a. Now I just simply multiplied a into a is a, b into c is bc. So eventually you're going to get a divided by bc. That is your format 2 for fractions. Whenever your numerator is in divided format, you write it like this. But then again, what happens if your denominator was in the divided format? For example, now you have, wait, this is your numerator, divide format. Okay, this is your case 1. And then again, you can have denominator divided format. For this denominator divided format, this is going to be a divided by b by c. Okay, now you can see that now your numerator only has a and denominator has b over c. So whenever this cases happens that your denominator is given in fraction, then I can write that a separately and your denominator will get divided now, like will get inverted now. So it will be multiplied with your numerator, but this time previously your denominator was b divided by c, right? Now as it gets inverted, so it becomes c divided by b. And eventually now I can again simplify and write it as ac over b. This is your denominator divided format or case 2. But what happens when we're working with a fraction where both the numerator and the denominator is given in a fraction? For example, if you have a divided by b and then again c divided by d. In this case, you mix up these two formats together. You write the numerator separately and then again you multiply that with your inverted denominator. Okay, you write the numerator separately and then that numerator is getting multiplied with the inverted fraction of your denominator. So I'll first write down the denominator numerator separately, that's a divided by b, and it will be multiplied with the inverted fraction of your denominator, which is going to be c over, sorry, d over c, because originally in your denominator you had c over d, and like inversion of c over d will give you d over c. And then again you multiply them, ad divided by bc, right? So these are your 4 types of fractions arrangements that you need to make. And another thing, if in some cases there are other 2 cases, for example, if I use it numbers. Okay, for example, you have proper fractions and then again you have improper fractions. What is proper fraction? Proper fraction is basically when your numerator is smaller than your denominator. Okay, for example, if you have 2 over 5, this is a proper fraction. Why do I consider that as a proper fraction? Because I cannot simplify it furthermore, right? Your numerator is already smaller than your denominator. I cannot divide 2 with 5. I cannot simplify it furthermore. So that is my first, like last stage over here. I'll not like simplify it furthermore. I cannot simplify it furthermore. But if we were working with improper fraction, then the case would be different. 5 over 2. And I know 5 over 2 is an improper fraction because 5 is greater than 2. And now as your numerator is greater than your denominator, I can further divide it and write it in the form of mixed fractions. For mixed fractions, this is how I'll write 1, 1, 2. And basically why do I write 1, 1, 2? That's because 2 with 1 and then added with 1 gives you 2. Divide by 2. It restores that same value. 2 gets multiplied with the side number and then added with the numerator. So 2 multiplied with the side number was 1. Oh, wait, sorry, made a mistake. This is supposed to be 2. Okay. Denominator and the side number gets multiplied and then the final product, 2 into 2 is 4. That gets added with the numerator. And in numerator, you add 1. So 4 plus 1 is 5. 5 over 2 will restore this improper fraction. So for proper fraction, You cannot simplify it. You cannot write that in mixed fraction. But for improper fraction, as your numerator is greater than your denominator, now I can write this type of fractions in form of mixed fraction. Okay, that is known as mixed fraction. Now, if you remember, we were trying to explain your formula 8 from that formula sheet. So let's start with that. For the formula sheet, you had a to the power of minus n, and then again b to the power of minus n. As I already know, minus n indicates 1 over a, right? Or something that indicates that this was actually belonging to a denominator of a fraction. So I just write minus a as 1 over a n, and then again 1 over bn. Now this is exactly in the format of your option 4 for fractions, right? Where both the numerator and denominator are separate fractions. For this kind of cases, when your both numerator and denominator are present in separate fractions, what do? I write down the numerator separately and I multiply the numerator with the inverse of your denominator. Okay, so I'll just write down the numerator separately first. That's going to be 1 over a power n, and this fraction, this numerator, will get multiplied to the inverse of your denominator. Inverse of your denominator means it previously you have 1 over b power n, now it will be b power n divided by 1. So eventually you're going to get b power n, a power n. That was your formula 8. Is there any questions till now for all the different types of fractions and proper, improper, and the formula 8? Any questions till now?
No, teacher.
Wait 1 minute. Okay, as I was saying, so now we are done with Formula 8. I hope that's clear for Afti and Fayad also. And then there's few very simple things. For example, um, 7 and 10 are quite similar, right? A to the power of minus 1 represents 1 over a, inverse of a. That is similar thing. And a to the power of 0. Doesn't matter whatever the base is. If you have the power as 0, the final answer would be 1. Try to calculate 125 to the power of 0. You'll get 1. Okay, try to calculate 256 to the power of 0. Anything to the power of 0 will always turn out to give you 1. Okay, and then again, this final, wait, sorry. Okay, then again, this root kind of cases. So what is this root? For example, if you have, I mean, so far for all the power formulas we saw till formula 10, we were working with whole numbers of power, right? Maybe in some cases when we are working with inverse, then your power got negative, but it was still a whole number. But what happens when your power comes in a fraction? So if you have a power of, I mean, 1 over 1 is not possible, right? That will eventually be 1. So that means the smallest fraction that can be like that is possible to create as a power is going to be 1 over 2 because 1 over 1 is not a fraction. So if you start to write it as 1 over 2, this fraction power has a unique sign itself that is referred to as the square root of a. Okay, so whenever you have these fraction powers, they have this square root function. For example, 1 over 2 is the base power, like reciprocal power. Reciprocal means the fraction power, okay? 1 over 2 is the base because nothing can be smaller than this. As I've already stated that 1 over 1 is going to give you 1. That cannot be considered as a fraction power. So the smallest fraction power any alphabet can have is 1 over 2. As this is the smallest fraction power, so I'm not going to write anything over here. So if you have only this symbol, okay, this symbol with nothing written over here, you have to like instantaneously understand that empty root indicates this is a square root, which means if I would have to write this empty root in terms of power, I would write 1 over 2. As this is the base power, that's why I'm ignoring to write anything over here. But if that was not the case for base power, if you have 1 over 3, in that case, it will be cube root a, and you have to write 3 over here. If it was 1 over 4, in that case it will be 4 root a. You have to write 4 outside that root sign. If you have a to the power of 1 over 15, I would have to write 15 outside that root power. Okay, only not writing anything or avoid writing anything over here for half. Other than that, if your power increases from half, for those other cases, you always have to write down the number over here. Is there any problem till now? Any questions till now?
No, teacher.
Okay. If there is no question, then we'll explain this thing again a little bit over here. So far, we understood that, okay, if you have 1 over 6, I can write this as 6 root a, right? But then again, if you have different fractions, for example, 1 over 6, I can understand, right? But problem is if you have maybe 5 over 2, how would I write this type of fractions? This type of fractions always try to separate the denominator from the numerator. 5 over 2 can be written as 5 multiplied with half, right? But then again, half is a root, so I can write root a to the power of 5. So if it doesn't matter if you write 5 over 2 or root a to the power of 5, they both mean the same thing. I hope that's clear. I'm just separating the denominator and I can understand this is the square root of base. I'm just writing square root a to the power of 5. Is there any problem till now?
No, teacher.
Okay, if there is no problem, then try to find out this one. A to the power of 13 by 3. Okay. What would be the final answer over here? No need to do this on your copy. Just let me know the answer in this call. Anyone got any answer for this question? How would I write this? A to the power of 13. Yeah, a to the power of 13 root 3. That means I'll write a power 13 inside the roots, and as you have 3 over here, 3 means that basically you have 13, 1 over 3. For this, I can write a cube root 3. So a cube root over here. Is there any question till now for this part?
No, teacher.
Okay. If there are no questions, then lastly in this part, I'll just remove all these things. For the last part over here, it says that a to the power of n, a to the power of y is basically x and y. Now, I cannot actually explain this question 13 because whenever on an equation, when the left hand side and the right hand side, they both have the same base but different power, bases gets cancelled out. And why does the base get cancelled out? Don't ask me why, because we can understand this in your P2 classes chapter 3 when we will start logs. Okay, question 13 and 14 is basically a part of logs. This will not be required for your P1 chapter 1, but I'm just writing this over here because these are also related to your surds and indices, which are actually going to be done in chapter 1. Not exactly this one, but somewhat it was related. That's why I wrote it over here. But they are basically formation of logs. Like on a log basical understanding, I can explain that why the basis gets cancelled out and the power stays on. And then again over here also why the basis gets cancelled out and the power stays on. For 14, I can explain. For example, if you have a to the power of like x to the power of a and y to the power of a, one thing to understand, whenever you're changing one power from one hand to the other hand, okay, from one side to the other side, it will be the reciprocal. So for example, if we start with numbers, if you have x square is equals to 4, what does the square become when it changes to the right hand side? It moves to the right hand side, it becomes 4 power half, right? That is, we usually write this as root 4, which eventually becomes 2. So that is the case for all of the powers. Whenever you have some power on left hand side and you want to take that power to the right hand side, it becomes the inverse. Inverse means it becomes the reciprocal of the original one. So over here also on the left hand side, if you have a, now when it will move to the right hand side, it will be 1 over a, right? And I know from my list of formula, power on top of a power gets multiplied with each other. So you basically have a multiplied with 1 over a and a gets cancelled out. Finally, you're left out with y power 1, right? That is the final power for y and nothing else other than that. Is there any questions from all the formulas we have seen so far from this file?
No, miss.
Okay, if there is no questions, I mean, we have seen these questions like these formulas already, algebraic expansion formulas, that a plus b whole square, a minus b whole square, and your a square minus b square. This will be again important for your rationalization, which is basically a part of 1E, 1F. But for the initial chapter, these are not required that much. So that was it. We are done with your formulas. Let's start with your questions now. We're going to start with question one, like exercise one. But then again, exercise one does not actually have that much of very difficult content. Let's start with the last two questions of question one. Okay. Now for this is question one, exercise 1A. Okay. For this one, you have 4y cube power whole cube divided by 2y cube. I can write this as 4 power 3 y power 3. On top of that, you again have power 3 and divided by 2y power 3. So then again, I can write, as we have 4 power 3. 4 power 3 becomes 64. So we basically have 64. Y power 3 multiplied with 3 will become 9. As now you would not have the same bases get multiplied with different power. This time you have one base on top of two, like one base with two powers, right? So now the powers will get multiplied with each other. 3 on top of 3 means 9. 3 multiplied with 3 gives you 9. And then again you have 2 y power 3. So I can understand these will get cancelled out, right? Because 64 is divisible by 2, which gives you 32. So this is 32. And then again, you have what? In this part, you have same bases with different power getting divided with each other. That means your second formula will be handy over here. We're going to take one y common and powers will get minus with each other. We eliminate it from each other. So 9 minus 3 turns out to be 32 y power 6. Always remember, whenever you're eliminating this, you never eliminate the denominator from the numerator, okay? You never eliminate numerator from the denominator. I'll never write it as 3 minus 9. That will be entirely wrong. Whenever I'm going to eliminate them, in cases when the bases with different powers are getting divided in this situation, it always has to be denominator subtracted from numerator, okay? So it will always be numerator minus denominator, not denominator minus numerator. This is your final answer then. After this, let's move on to point Q. For point Q, again, you have this similar kind of pattern. So you have 2a power 3 divided by 3a power square, and with this 6a power 5 well multiplied to each other. I can clearly understand what exactly is happening over here. So if you just focus on like the division part first, you have 2 over 3 multiplied with 6, right? If you just focus on the numbers, this is how it will look like, 2 over 3 multiplied with 6. Okay, and then again, this is multiplied with a 3 minus 2, and then again this will be added to 5. Why exactly? Because this fraction is in multiplied format with a to the power of 5, right? So that's why 3 minus 2 is for the fraction itself, and then again plus 5 for the product. So eventually you have wait 1 minute, this is 2 over 3 multiplied with 6 gives you 4, and 3 minus 2 is 1, 1 plus 5 is a to the power of 6. And that is your final answer for question Q. Is there any question till now?
No, teacher.
No, miss.
Okay, 1 minute. Now we are done with P, Q, R. I'm sorry, not R. Let's do R over here. R is easy because I can understand all of the numbers are getting multiplied to each other. Again, if you do not have any number in front of an alphabet, that indicates it has one there. So basically, for the numbers, if you focused, you have 3 multiplied with 2 multiplied with 1. And then again, this is multiplied with a power 4, a power 5, a power 3. That means now your value for a will be 4 plus 5 plus 3. How can I add the values? Because remember, you do not work with the coefficients, you work with the base, right? A power 4, A power 5, A power 3. They must have different coefficients. Coefficient means the number that is written beside the alphabet. Okay, like 3 is a coefficient of A power 4. They must have different coefficients, that is true. And we are adding, like multiplying their coefficients is normal number. But for these alphabets, as they have same bases, we can add their numbers, add their powers to get the final power. So it is going to be 4, 5, 3 all added together. And you're going to get 6, 9, 10, sorry, 9, 10, 11, 12. So you're going to get a power 12, 6a power 12. That is your final answer for question R. Right, for question 1, in exercise 1A, you basically have to simplify this powers methods. Nothing that much other than this tricky. Let's move to question 2, where you have to expand terms this time. For question 2, let's start with, then again, let's start with the last three ones, T, U, V. For question T over here again, 3x squared minus x, 3 minus 4x plus 7. Over here, only this x is getting multiplied with everything inside the bracket. Okay, the 7 and 3x are going to get added with the final product, whatever you're going to get after we're done multiplying. But before multiplying, we cannot simplify it anymore. So basically, we have 3x squared. 3 into x will give you minus 3x. And then again, you have minus x minus 4x. So eventually, it will be plus 4x squared plus 7. So now you can see 4x squared and 3x squared, it will be 7x squared minus 3x plus 7. Now I can understand that obviously this is a quadratic equation, but I will not simplify it furthermore, okay? Because in this part, they only wanted you to expand these statements outside the bracket. You need to simplify this, okay? No need to complete the factorization over here furthermore. We're just going to expand them and keep it over here. Nothing to do after this. And similarly, same kind of concepts will be applied to these questions. This is, I think, U. That means 4x is getting multiplied with whatever you have inside this bracket. That is basically x plus 3. So you have 4x multiplied with x is 4x squared. 4x with 3 is going to be 12x minus 3x. And 2 is going to be negative 6x squared. And then again, minus minus, you have positive 2x with 7 is 14x. And now you have to simplify it. For example, you can add or subtract the x's squared together, and then again add and eliminate the x coefficients together. You have 4 minus 6x squared. 4 minus 6 means you're going to have minus 2x squared, right? At the end. So you're going to get minus 2x squared, and then again 4x plus 14. Sorry, 12x plus 14 is what? 26x. This is 26x. Now, question R is actually a classwork. Can you guys do this for me right now in class and then send me your working in WhatsApp? I hope all of you have your phones available with you, right? Please do this in class and send entire picture of your working in WhatsApp. Not just the answer in the text option. You have to do this maths with every steps and send me your working in WhatsApp. For our maths classes, this is how I will actually conduct the classes. In between the classes, I'll give you one or two classwork so that you guys can see, like, do that working inside the class during the class timing and send me a working in WhatsApp. We will also create a group where I will update about the classes and everything. And in case for this type of classworks, you can also send your pictures in our groups also. I think you made a mistake. That's 3, 3, 15. Okay. That's the correct answer. Yeah, 6 x cubed, the next pair. 1 minute. I'll do this over here for a little bit confusions. For example, if you're starting with 3x square, then 2x plus 1 and minus 5x square, 3x minus 4. Right, this is your original equation. So when you're multiplying 3 into 2, you're going to get 6x power 3 plus 3x square, and then 15x power 3 minus minus, you're going to get plus 20x square. So basically at the end, you're going to get 6 minus 15 is minus 9x power 3. And then again, this is 20 by the way. 3 plus 20 is going to give you 23x square. Right, that is your final answer. This is supposed to be your final answer. Okay, most of you got it correct. So I hope, I think this is how mostly all of the questions from exercise 2 will be. Question like chapter 1 is not that much tricky, so I'm not doing much maths from there. But for your question 3, this is for simplification. And I can understand I cannot divide two numbers in the numerator with only one number in the denominator, right? So what I will do over here, this type of fractions is again extremely important for your integration differentiation maths that will come in your chapter 7 and 8 of this unit, P1. This is question 3. For question 3 over here, I can understand that I need to simplify it, right? So in order to simplify it, I can write 7x power 7 divided by 5x. And then again, you have addition in between the two numbers and denominator. So again, you can write 5x squared divided by 5x. Now I can understand that obviously I cannot divide 7 with 5, right? Both of them are prime numbers. So I'll just write 7 over 5. But then again, for the alphabet, you have x power 7 and x power 1, right? Nothing on the top indicates you have x power 1. So as same bases are getting divided with each other with different powers, so you can write 7 minus 1. And then again plus 5 and 5 can be cancelled out, and then again you have x, I mean over here 5 over 5 will give you 1, right? And again in front of alphabet you have an invisible 1, you do not write that. So on the power again you have 2 minus 1, right? Because on the base you have 1. And after this, you can write 7 over 5 x power 6 plus x power 1. 2 minus 1 is 1. Then again, on power also, if you have 1, I'm not going to write that. Okay, x to the power of 1, 1x. For all of these situations, I'm going to avoid writing the 1. And let's move on to f. For f over here, you have 9 x power 5 minus 5 x power 3 divided by 3x. And similarly, I'm going to separately divide that 3x with the two numbers on the numerator. So you have 9x power 5 divided by 3x minus, in between the two numbers in the numerator, you have now have minus. So we'll continue with the negative sign. So 5x power 3 with 3x. Similarly, 9 over 3 can be cancelled out. That will give you 3 in the numerator. So basically have 3x power 5 minus 1, and then this is subtracted with, I cannot subtract 5 and 3 together. Again, they are prime numbers. So prime numbers cannot be simplified anymore. So you have to write 5 over 3 and x power 3 minus 1. So basically you have 3 x power 4 minus 5 over 3 x power 2. Right? That is your final answer. E and F. Is there any question till now for question 3?
No, teacher.
Okay. If there is no question, then we're actually done with 1A, and we're also done with the end of our trial classes. So this is it for today's class. In the next classes from Tuesday onwards, if you continue with the P1 classes, in that case, our classes will start from 11 a.m. for Qatar timing and 2 p.m. for Bangladesh. And we will start with 1B. Okay. I would suggest before Tuesday, if you guys want to, please trust, practice the other maths. I mean, over here, I only did the last 2, 3 maths for each question from 1A. I would suggest practice the other maths from each question from this section. And from the next classes, we're going to start with 1.2, or that 1B expanding brackets. Okay. From the next class, as we're not going to waste the timing to explain the units and everything, we can complete 1B, C, and wait. Yeah, we can complete B and C together. What is in D? 1 minute. Yeah, we can also complete DDs for those reciprocal powers, fraction powers. We can also do that. For E, that is different, okay? E is different because E works with rationalization, which is, to be honest, the difficult part from that is not entirely difficult, but compared to the other 4 units, 1, E, and F are a standardized maths. A, B, C, D are very easy. Okay, then, thank you for joining the class over here. I will stop the recording till now, and these recordings will be uploaded in my YouTube, and I'll give you guys the link.